Hi guys, welcome back to my channel. So in this video we're gonna go over flow control instructions. Okay, so basically every instructions that we have covered so far doesn't actually affect the execution flow of the program, right? So but what about the situations where when we have like loops, if statement, switches? Okay, so when these types of instructions are involved, so in here we have like some sort of branching and jumps. Okay, so let's go ahead and talk about branching and jumps. Okay, so branchings and jumps are basically like the instructions that changes the program counter. Remember the PC, the program counter. So both of these instructions, they perform basically the same goal. Okay, so they're like basically doing the same goal, like jumping. Okay, but the implication by the name is different. Okay, so what I mean by that is like branches, they tend to be like local in the memory. Okay, but when you're talking about jumps, okay, so the jumps, they span like a larger range in memory. Okay, so overall the difference is basically dependent on the processor design. Okay, so basically, you know, branches, they involve an offset to the program counter. Okay, so the and the offset, if you want to know, it's encoded into 2's complement. Okay, and since the offset is encoded into 2's complement, there's going to be like a limit range that the branch could actually reach. Okay, so let's say we have this this assembly code over here. Okay, and if you don't understand this code, you can go ahead and check out the playlist. You'll find I made a video on how to read this, so you'll understand it. So for now, let me roughly go over this. Okay, so here it is asking like what is the value of R1 at the end of the snippet. Okay, so what we're doing over here is we're adding 0 to R1, right? And then we're adding like storing 0 to R1, then we're adding 1 to it, and then we're adding 4 to it. So before the value was 1, now we're added 4 to it, so now it becomes 5. And now we have here the example of a branch, but here we have the branch with a label skip. Okay, so we have the branch with the label skip. So what we're going to do, we're going to like move from here to here. Okay, so whatever is in the middle, we're not performing it. Okay, so we're like skipping it. Okay, so we're like going from here to here, like sort of a jump. Okay, so from here to here, and then what we're doing, we're basically adding 10 to R1. So we figured out it was 5, so now we've added 10 to it, so now it becomes the R1, the value of R1 becomes 15. Okay, so like I said before, like I said over here, the branches, they involve an offset added to the program counter, right? So here when assembling, okay, so assembling is basically like the process from converting assembly code. So we have an assembly code over here, right? So when assembling, so we're converting this assembly code into machine code. Okay, so this is what means by assembling. Okay, so we are converting this assembly code into machine code. So the assembler will actually, like during assembling, it's going to determine the offset of the labels. So the offset of the labels, here we had this label over here, right? So it's going to determine the offset of the label and then encode it into the instruction. Okay, so for example, let's assume in this example each instruction is 2 bytes. Okay, so if each instruction is 2 byte long, then the assembler will commute an offset of +2 over here, right? So this is going to produce an equivalent expression. So it's gonna produce an equivalent expression of like branch with an offset of 2, right? So and of course we cannot go ahead and encode. So yeah, we cannot like encode labels in actual machine code, right? So the assembler does the computation for us. Okay, so like if you go ahead and ask me the question like why branches 2 bytes, okay, so like why 2 bytes? Okay, for this you basically have to know that the PC register is going to point here, like here. Okay, the PC register is going to point here during the execution portion. Okay, so by that what I mean is that the assembler knows the PC register. It's gonna know like the PC register will already be incremented to point to the next instruction. Okay, so like the PC counter, it's like incrementing to the next instruction. Okay, so yeah, so it's basically doing what? So it is incrementing to point to the next instruction. Okay, so the PC was this, right? So it's gonna go ahead and add an offset to it, an offset of 2, right? Because I explained here, right, the branches involve an offset added to the program counter. So in this case, since we assumed it to be 2 bytes, so it's gonna go ahead and increment it to point to the next instruction. So then the PC, it's gonna become like PC plus 2 with an offset, right? So so the, like I said, like because of the 2's complement, you know, it has a range. So the range of branches is limited, right? So this is like on how much space is available to encode an offset, right? So this is what basically the limit is telling you, right? The space needed to encode an offset. Okay, so for the jumps, like I said, the jumps access larger range in memory, right? So the jumps, they can come into 2 flavors. Okay, so the first one, it can be like absolute address. So we have the absolute address given to us, but it's gonna be encoded into the instruction. Okay, or we can like use a register. Okay, okay, and then like jumps, just like branches, you know, they're gonna have labels as well. So like you will have labels in assembly to determine like where to jump to, right? So I will show you an example of the jumps just in a while. Okay, so just remember, jumps, they're not going to use an offset just like how branches did. Okay, so here this does not involve any kind of offset. Okay, so an example of jump would be something like this. Okay, so we have an example of jump over here. We're like here you see jump to there. So here you have jump, and then you have a 2 there. This is like the label. Okay, so from here you're jumping to here. Okay, and whatever it's in the middle, you're just ignoring it. Okay, so this would be an example of jump. And so like whatever I have covered so far for the jumps and for the branches is basically unconditional, right? So we do not like have some sort of conditional involved. So like so how do we do, like if we have like conditions in the branches and the jumps? Okay, so let's go ahead and talk about that. Okay, so the branches and jumps, they have condition codes. Okay, and if these condition codes are met, then the instruction is executed. Okay, so the condition codes are based on the specific values of the status register, and those values could be like for example E, which stands for if equal. Okay, and it could be NE, which means if not equal, and L less than or equal to, greater than equal to. Okay, so with this in mind, we can use like branches and jumps with condition codes. So okay, so with this in mind, we can use branches and jumps with conditional codes. Okay, so we can have something like this. So some label. So this basically means jump to some label if equal. Okay, jump if equal. So you're going to jump to some label if it's equal. And BL, which means branch to some label if less than, and BEQ, which means branch to some label if equal. Okay, and BNE means branch to some label if not equal. Okay, so jump if equal, branch to some label if less than, so branch less than, branch equal, branch not equal. Okay, so we can go ahead and do an example of this. Okay, so for example, let's say we have this this code over here. Okay, and we want to write this into assembly code. So how we can do this? So you see over here we are comparing two values, right? So to write the assembly code, what we're going to do, we're going to write CMP compare R2 and R1, which is, so R2 and R1, let's say R1 is, let's assume R1 is A and R2 is B. Okay, so we're going to compare R2 and R1. Okay, and if R1 is greater than R2, then we're gonna do branch greater my if. Okay, so here if A, the value of A is bigger, so then we are going into the loop, right? I mean the if statement. So then we have to write here the condition for the my if. So if the branch is greater, right, so we're going to go in here like directly from, so we're gonna skip whatever it's in the middle, we can directly go from there to here. Okay, so but we have to write what's in the middle as well, later we'll write it. Okay, so what's going on inside, we're simply adding 2 to A and subtracting 5 from B. So that's what we're gonna write over here. So we're simply like adding a constant of 2 to register 1, and then we're adding -5. Okay, and yeah, so that's basically what we're doing. Okay, so if this is not true, so then what do? We go into the else block, right? So we're gonna have to write it over here. So if this condition is not met, so then it's gonna go over here. If it's met, then it's gonna move in here, right? So here what we're doing, we're simply adding A plus B and putting it into A, right? So what we're doing, we're like adding R1 and R2. So this basically means add R1 and R2 and store the results in R1. Okay, okay, and okay, so after we have we have just done this and this, but we still have this left, right? So here like if it doesn't go into the if, right, so it's gonna go into the else block, right, which is this one. So now if it go in here, and then it's gonna move on to the if, but no, we don't want this to happen. So what we're gonna do, after the else, it should go in here, right? So we're gonna put like branch over here, like branch, let's say end if, you can call it anything. So end if, and then you will actually go ahead and put the condition for end if over here. Okay, so I hope it's making sense that first of all we're comparing the values, and if the R1 is bigger, then we're moving to the if block. Okay, but if it was not true, then we're moving to the if, and then of course afterwards we're going to the end if. Okay, but if it's not true, then we're going into the else block, and afterwards we're performing this end if, which is coming over here. Okay, so the end if, what is the condition for that? We're simply adding 2, right? Oops, I made a mistake. It was multiply over here. So if it's multiply over here, so we can go ahead and write over here R2. Oops, we can go ahead and write like multiply R2 by 2, right? So this completes our assembly code, like when we're given a code and we have to put it in the assembly code, and the teacher basically said, I remember, like, this is important for the midterm and you guys have to know how to write these things.